Hey folks, before we get into today's podcast, I wanted to share that QCon London returns April 7th to the 9th, 2025. Learn what's next from world-class leaders pushing the boundaries of modern software. You'll learn actionable insights from senior developers working on real-world projects across multiple domains. Learn more at qconlondon.com.
Hello everybody, I'm Olimpiu Pop, a Java veteran editor for InfoQ, but I typically write about data and machine learning, and tonight we are together with Max Rydahl Andersen, talking about how we can complicate our lives as software developers, principal, and who other people we might be, especially now in the era of AI. And let's hear from Max. Max, who are you, and what are the projects that you're currently working on?
Hey, yeah, I'm Max Rydahl Andersen, as you perfectly pronounced.
Almost.
I worked in the software industry for, 25 years. 20 or so of them has been in professional open source. Started in JBang, then RedHat, and I started in Hibernate. I've done Seam and tooling. I spent like 10, 15 years in Eclipse tooling and IntelliJ tooling, VS Code, that kind of thing. And then I was off for a few years for doing other stuff in Go. And then I took a year break, which actually triggered a lot of stuff we talk about today, like realizing, getting away from all the complexity and realize, man, it's really complex when you come back. And what I've lately been doing is I'm a co-lead on Quarkers, and my side project is a project called JBang, and both of them are about making it fun to develop Java again, so to speak.
Okay, thank you for the introduction. That's a really impressive path that you walked on, and it's not even getting started, right? So obviously nowadays everything is about AI. If you put on a chocolate AI, it will just become more popular probably. How does that change the way how we used to build applications?
So that one is a fun one. So on one hand, I think it's amazing what's happening. And when I saw it the first time, I was like, wait, what is this? And to see a lot of opportunity in it. Like I'm pro AI, but I'm anti the AI hype. So for me, this AI is going to enable a lot of interesting ways to interact with IT, and enable a lot of people who not before could use IT to utilize it better. And I'm definitely not a person that thinks that, oh, this AI will remove our jobs, at least not in the near term, because as we get more people able to use computers, the more the backend needs to do. And I have this, I think I tweeted this out at some point. I said, if AI disappears tomorrow, the world will continue to work. But if Java disappeared, the world will stop, right? Because all this stuff that AI does is interacting with these systems out there, at least today. It might be changing in the future, but it's very much the thing. So I'm frustrated about all the hype that says that if you can just do AI, you can do everything. I'm like, no, you still need to understand like system thinking and engineering to do it well. Yeah, it's a fun.
Let me draw a conclusion somehow of what I heard from you. Mainly, it's a tool, another tool in our toolbox.
Yeah,
but we still need the basics.
Yeah.
System thinking, critical thinking. And actually, for me, the interesting part is the fact that now we really have to be product developers. It's something that I always preached about, but people were like, okay, I know Java or I know JavaScript, and it's more than enough. Now you really need to understand everything between you and the customer and the system, because obviously that will be the thing that will allow you to build a system that needs to be done. And then obviously you can just do some stuff with generative AI, but you still have to create the box or the guardrails for that.
Yeah, for me, the AI is definitely a tool, but it's like I compare it to like when SQL came around to access databases. It's a thing that people like we use everywhere now in all different systems, all different ways to access data. It's kind of been a standard way to get data. And LLMs or AI, I think, is this tool that yes, if you only think about like prompt engineering, like use it, like if you had this like chat view on it, then it's definitely a tool you can use to learn stuff with. But once you start applying it, you also realize, oh, I can use this to get started writing my email. I can use it to write my code. I can use it to write my workflow. Oh, I can use it in doing stuff for me, which are boring tasks, right? Well, so for me, this thing, it will enable people to do more. Therefore, it's not AI who's going to take the work away from you. It's someone else who's using AI to do your job better, right? It's just leveling up what we can do and enable way more people to participate in software development, which is amazing, but it's also super scary because it means now that people before, there's like a natural filter because they had all these good ideas but couldn't execute, and they need to go find someone who could turn it into code. That filter is no longer there. You can literally just, over time, there'll be AIs that can help people with crazy ideas get implemented. And some of them will build amazing things. But man, there'll also be even more people creating stuff that is horrible and unmaintainable and perform like really bad. And that's why I keep saying that you still need to have a good understanding of how things work. And at least, as far as I can see, all the limits of LLMs lies in like, it's not kind of going to come up with like new ideas, but it is going to help someone with good ideas to maybe get some other ideas and get some, hey, there's something related to this, and therefore execute faster. It's a very interesting concept. Yeah, and for me, I think, it's going to be a tool we use everywhere, but I'm bullish on it's going to remove all developers. Because remember when the mobile first came around, like, hey, now everyone's going to do mobile apps and desktop is no longer. But if anything else, yes, we have all mobile phones now, but we have even more desktop apps and even more powerful software that runs locally.
Yes, I agree with what you're saying, is that currently it seems that the mobile apps, and even if you look at mobile, tablet and laptop or PC or whatever, the whole ecosystem, you do different things for different stuff. Well, I don't know, maybe I'll just text you a plain message, but if I need to write a more comprehensive message, probably I'll just still pick the full keyboard to do it. And that's my feeling also with LLMs. They are very good at particular tasks, or how I envision them is another entry point for your application. It's a simple way of interacting, and that's something that you have to build on top, and obviously crunching other numbers and allowing us to keep up with all the information that comes.
Yeah, 100%. And another analogy is the stuff like, remember when there's only assembly code or even, punch cards? Very few people can do it, but there's more and more IT. We got assembler, then we got high level languages. Every time we expanded the number of people who could do this stuff, and every time we said, now it's simpler. So we don't need, we can do more with less people, but we're still growing and growing and growing, and there'll be more and more demand. And AI is literally just doing the same thing. At least that's the way I see it.
I agree with that. There are things that they'll be useful for, and I like it. For instance, one scenario that I'm looking currently at is using LLMs for configuring some complex IoT applications, because it's a pain, and that will allow us to make things a lot easier and more secure. But obviously there are steps that are validating those things implemented separately. But given that now we are sure that we'll have a job tomorrow and we still need to write code, let's go back to the other projects that you're involved with. What we were discussing is that we as a branch, as a craftsmanship, we have a tendency of complicating things. And theoretically, we should make things a lot simpler. And that's something that I know that you strongly believe in.
Yeah. So one thing is I said, like, I spent 15, 20 years in the industry, and then I took a year off. And I remember the first thing that happened, like when I started, I said, I'm not going to go and use a computer for like 3 months or 6 months even. And on my first day, I fell and broke my ankle. So I couldn't do anything. So I actually had to go and use something. And I said, no, I'm not going to go and look at Java. Let me try something else. I did Python in my old life, so to speak. And I went back to that, and I actually did some home assistant IoT stuff. And I realized, oh, this is actually fun. There's some pleasure in this like non-type safe world, but I also like, man, it's also complicated. But it was fun. And then I had a year off, didn't do much Java, but I heard about my friends in Red Hat who were looking at this project that was looking at Java differently. But I was like, nope, I'm not going to touch it. I'll hear what it does, but I won't touch it. So I came back a year later, and I had to go and install Java, learn how to run the build tools and Maven and that stuff again. And I was just, man, like, what have we created? So one of those things was, like, I came back and I worked on a project called Quarkus then. And what Quarkus does is it came out of, hey, Java is dying, or that was at least the theory, because, we can't run in the cloud. And we looked at why is it they can't run in the cloud? And that's because it runs on these like less resource machines, and Java is kind of built for having access to many cores and a lot of memory. And we talked to the JDK team, like, can't you just make it faster? Like, just make Java faster, it'll be fine. But I said, well, the best way to make Java faster is to have less classes, because what takes time is every class coming up. And it turns out that that's like, if you do a hello world or something else, it actually starts very fast and doesn't use much memory. But even better was that we realized, hey, the same application runs, and a lot of like Jakarta EE or Java EE at the time, Spring Apps, Wildfly, Seam, they were basically building on booting up the VM, doing a lot of configuration at runtime, and then wire things up magically. Like, we call this simple, simple and powerful, but in reality, we were basically doing the same thing again and again. And every little dynamic thing, every little small thing was cool and useful, but we were basically doing what's called 1,000 paper cuts. Like we just piled up these things. And in Quarkus, the approach we take there is like, let's just do everything at build time, or move everything at build time. And then suddenly, when you do everything at build time, all the parsing and handling of configuration, we can kind of throw away and leave behind the result. And then suddenly, you get a JVM starting up in like milliseconds or less than a second. And then you can apply like native images on top, and then it goes in faster. And that flipping things around and not dragging in all the complexity we built over the last 25 years was an eye-opener for me, because suddenly I was like, wait, we should just do stuff at build time. And off we go. And then on top of that, so this gives us like good runtime performance, which was the main thing that I think people know Quarkus for now, and also what was the interesting back then. But on top of that, because we were so fast of doing this stuff, and we did build time, we have this information about the project, we can do stuff at development time too. So we actually could do hot reload or live reload. So you get this, let's say, the Python PSP experience, because you can just kind of experiment, which is a thing we're not that used to in Java. And that was an eye-opener for me, that suddenly we can do this, where before my past of tooling experience was, I have to write a IDE plugin that does the live reload or handle this stuff. And we were fairly popular, but it wasn't until I actually went away from the tooling space and realized, we had 100,000 whatever users per month on this stuff back in whatever year it was. But I realized we had way more people using EAP and Wi-Fi. And I realized most people never got to have that benefit of quick turnaround, because it requires to install an IDE and a specific plugin. And again, bringing it back to the runtime, makes the runtime a bit more complicated, but for the user, it's a much simpler experience. It's like, it just works. And that's a big thing for me, at least. Yeah.
I remember a presentation that Holly Cummins gave a couple of months back. I don't remember exactly when. And I resonated with her experience. And she was mentioning that, like you, like me, at a given point of time, we left Java behind and we did something else. We used another ecosystem. And the powerful stuff was that you can see the results quite quick. For instance, in a JavaScript or an HTML or Node.js or whatever, you just refreshed and everything was just popping up. And then looking at the way how Quarkus is approaching that, or let's not hold it only for Quarkus, but let's call it the third generation of web frameworks, because if you look at it, we used to have the heavyweights of the enterprise Java back in the day, the AGBs and so on and so forth. And then you had Spring that wanted to be a Spring, but now it felt more heavyweight. And now the Spring seems to be the heavyweight champion. And then you have the Davids coming behind the scenes, the Quarkus, the Micronauts that are trying to do the things differently. And it actually makes sense, and it's closer to what we started putting in the modular system. So we take with us only what we actually need and when we need it. And on top of that, it's also the ecosystem where you're just writing the tests, you save them, and in behind the scenes, the validation is happening. So now it's something that is more fluent. It's closer for me maybe to continuous deployment mentality that's more popular nowadays.
Yeah, the continuous testing, as we call it, or we have it under the name of developer joy. Like you should feel like you can just experiment and try things out. And we talked about AI, for example. This is a thing that when we started doing this thing, like we had the hot reload, we had the continuous testing, we added dev services with this notion of if you haven't configured anything, let's say you added a Postgres dependency or a Kafka dependency or something. Because of Quarkus, we only add stuff you need. We can derive that you want this. And if you haven't told us what you wanted to connect to, like Postgres, we'll just create one for you. So this is where we use test containers, or like we call it dev service, which uses test containers to start up either a Docker container or even a native image. And then this lets you get started very quickly. And the latest thing we've done here is actually in the AI space, just to talk about AI again. In Quarkus, with the LangChain for JA stuff enabled, again, it can do all this thing like hot reload, continuous testing, native image stuff. But it also comes with, if you set up your AI service with OpenAI or watsonx or Azure or whatever, we have a chat UI for you in the dev UI. So you don't even have to write code or try it out. You can actually try it out indirectly in the dev UI. But if you are more to local models, or using Olama, we will actually fetch that model for you, and off you go. So the same kind of automatic setup we can derive from what you have included and what you have configured, or rather what you haven't configured. Like this is like, I've tried to explain it a bunch of times, and I'm probably also failing at it again, because what I tend to see is like some people get it, but it's only when people actually try it out and they realize, oh, this magic happens, right? It's really fun to see that people who are used to using EAP, Spring, any other framework in the last 20 years in Java, they expect it to be hard. So people, they don't even try out the dev mode because they want to use the Maven build. And they used to do Maven build, run the jar, Maven build, run the jar. And in the beginning, there's people who were visibly upset on Twitter and whatever was there, that, hey, you're doing this hot reload stuff. I want to do test-driven development first, right? And that's where we came from. We made a continuous testing, so you can do both testing first and this exploration. My point is that the people, like even today, we can get to, most people that use Quarkus sees all this stuff and then all the good stuff, but there's a lot of people who just use Quarkus as if it's any other old system, and they never actually realize the power that's in Quarkus, because they just use it as they used to use any other complex setup.
So we should become more open-minded to change the old paradigms, because one of the things that come with, let's say, more tenured software developers, like you, like me, that you're above 20 years experience in the field. I am a bit below under that, but more or less around 20 years in the field. We were quite proud of the shortcuts that we know with our IDE and the way how we build the stuff.
Yeah, we have what I call survivor bias, right? That to use this stuff, we had to do all these complicated things, and therefore you should do it too. And when someone comes up with a simpler solution, it is hard to realize, oh, wait, this is actually better. And given like the world situation and how fast-paced thing is, I don't blame people for missing it because like there's just limited time to try things out. But it's something I remind people about again and again, like just give it a try and see how it works. And I heard multiple times now where people who had like this user case where they had like some PHP and some JavaScript and a few other things, and it was getting to be a mess. And they tried to roll Quarkus in, and suddenly they realized, oh, we can actually do all the stuff you're doing there in Quarkus and all the hot reload. And that was because it was people who were not used to Java. They just tried using it as they were used to in JavaScript and stuff, and they were like, oh, actually, I can actually do this. And they get all the benefit of the Java ecosystem and all the stuff that's there, and everyone's happy.
Yeah, I agree with that. But there is always the writing that is usually on the medicine that is very, very small and not everybody sees it. And in my experience, it's very nice when everything happens magically. But at points, there are the 99 percentile when things are not working as you expect, and then you have to go into a debug mode. What happens with those simple, because actually what all the simple stuff that we are mentioning, they are very complex behind the scenes, but it was built so well that it allows us to build simple stuff. What happens in that particular case? Will we drop the tool and then run for the old one, or what's your experience in that?
I can say what kind of mentality or approach we take in Quarkus is because there is machinery behind it, right? Like it's you're doing build time manipulation, there's bytecode generation. As the end user, you don't have to realize it, but sometimes you hit a wall and you get exposed to some of this stuff. So one thing we tend to do is anything like exceptions. Been around Java since forever, but since forever, how many versions was it that Java has just null pointer exception and no explanation of the context? It was added in like 21 or 20, I can't remember. At some point they added the null pointer because variable X is null, right? Simple little piece of context makes a world of difference. Imagine if that had been around like 20 years ago. And we do the same thing in Quarkus. We try any exception we find where we just say, oh, error. We try to add that little bit of context to help you. Similar, if you run in dev mode, because that's the thing we can with Quarkus, we can run in dev mode, so we can actually handle errors differently than in prod mode. So when an error occurs in production, we will kind of hide it because you don't want to leak details through a running system. But in dev mode, we know it's not running live. And we will actually give you the exception. And in the recent version, we actually even extract the source code so you can see it on screen. Like, this is where the issue is. And you can click on the source and go over. Again, all this without any IDE installed. And we just try and enable people to be able to solve the issues with context. And in some cases, we even go and explain, like, this is the kind of code you need to write, or look for these annotations, or and then we try and make sure that it's easy to find, like, all the debug tools that are there, enable logging, that kind of thing. And like the speed of how fast we can restart makes it so that, you might have an error, but you can try like 50 different things in 50 seconds, where before it will take, like, you do 3 or 4 things and it will take a whole day. And that speed in itself enables much more debuggability. Is that a word?
It is now. We just coined it, so we have it on tape.
Yeah.
Just thinking about what you mentioned about the exception and the way Java handles exceptions, I was just reminding myself about what James Gosling was saying a couple of years back in Antwerp at Devox Belgium. And he was saying, like, everybody's complaining about why we have typed exceptions in Java. Why do we have to put a catch exception everywhere and wrap everything in that? And then he was just saying that when he initially started building it, it was thought about embedded software. And that embedded software was running on the floor of the ocean. And he said, okay, it wasn't that easy to go and just press the reset button on those submarines under the sea. So that was the reasoning. And my feeling is that that's how we usually do. It's like, like the pictures where this is how we thought about it, like software developers, but this is how the user uses it. And even Java was used in that way. Now my feeling is that it's moving in a different rhythm. the community is more involved, and with this bi-yearly cadence, it's much easier. But how easy it is to maintain such a cadence? Because on the other side, when you're building simple stuff, as you said, it might be a pain in the back.
Oh, yeah. Man, it was a turning point for Java when they moved to the 6 months release cadence, because they did get into a mode of, oh, things can now evolve and change, which was super frustrating in the early days. It took forever to get stuff going in Java. And in JBoss and like in Hibernate and in Wildfly, and we've had to do tons of workarounds because of limit. Like the JVM was just not moving. For example, the whole async IO in Java came fairly, it came fairly late. And when it came, it was subpar compared to like Nady and other ways to do things. So Java has always been good because of a really stable OpenJDK and the ability to hook things in and rewire things so that it could be innovation in the higher layers. Now, we got multi-line strings, we got records, we got streams, I'm missing a few virtual threads. All those are definitely helping. And in Quarkus, we picked up all of them, but we have to realize that the people we are selling to, like the people that actually are paying salaries, they are companies who do not afford to update to the latest, greatest everywhere, right? Especially on the JVM level, because that's considered like part of the OS. So the fun thing is that people really want to stay back on the old version of Java, but they're fine upgrading to a newer version of the framework because people used to it changed there. And that leaves us in a funny situation that right now we've moved to, our base is Java 17, but we recommend Java 21. But here in a few months, Java 25 is coming out. And in normal cases, they'll be fine. But in Java 25, they've done a few things. Oh, not just in 25, but between 21 and 25. They've removed something like Security Manager, which actually makes it so that parts of the Java ecosystem just cannot run on 25 anymore. It's going to be fixed, but it's going to take some time. But that means that even if we wanted to move up to like 21, we still will have parts of the Java ecosystem that could just not run on 25. So even if we wanted to move to 25, we can't because it's still on 21. So all that stuff will still exist. But we've done this in Quarkus that we do basically releases every month, like multiple times a month, actually. Like we do a minor every month and several micros depending on bug fix and that kind of thing. And that has allowed us to have fast iteration, but we have a stable version called LTS release. So we kind of do what is done in Java, like this tip on tail system. But we are not doing what the OpenJDK team is telling us to do, or was pushing like last year was this like do a release on the latest version of Java, like have a version of Quarkus that has a baseline of 25 and then just maintain an old one for 21, for example. That requires just too many resources to make happen. So instead, what we do is we survive by using older version of Java in the framework, but we can still support newer stuff like 21. Virtual threads was supported, like even when we were on Java 11, we had support for Java 19 virtual threads. Java 14 records was supported before we moved up from Java 11. Whatever the new specs are, we will have support for them, but we won't be able to use them ourselves in Quarkus. And that's the price we pay so we can be on the edge, but also still support the older, I'm not going to say older, but slower moving systems.
In those places that usually make the world spin, because I worked in finance for a long period of time, and I was surprised that people were still happy with software that they bought 10, 15 years ago, because it was doing the job that they always did. And
yes.
It was just great. Occasionally, when there was some kind of regulation change, they were coming and asking for an update, but mainly because they needed that feature. But the things were working. I call them the plumbing systems. You don't care about the plumbing underneath your house as long as it's working as expected, but you'll definitely care when the water is just popping out.
Yeah, that's just the reality of things, right? That like we have older version of Quarkus that we know are in production and we help them, but Quark is still, all things considered, still a new kid on the block,
Yeah,
right?
the new kid on the block.
So we still have the benefit of being able to move up, but we are introducing like LTS and longer LTS, and over time it'll get longer. But we've been very aggressive of not guaranteeing like a version of, let's say, Quarkus 3.2. We will not add any new features to it. We will maintain and do security fixes to a certain level, but all new development move up because it is a new world. We are encouraging developers and companies to, no matter what, build your infrastructure and your CI so you can do this continuous testing. So updating should not be a problem for you. We believe that will cost less to develop and it'll be cheaper to maintain. But eventually, some project will be like, hey, we can't keep updating. We'll just stay on this long-term server, and then they won't need. They will also not need any new features. That's fine. We'll just keep maintaining that. But yeah, this is the thing I think is exciting over the last 20 years is that software companies, even the older legacy ones, are getting into the mindset of being able to update more aggressively. Which is the thing with the whole AI phrase. I'm still waiting for. Everyone talks about all the cool stuff AI can do, but if it can do that, it can also exploit CVEs way faster than anything else. So being able to upgrade is going to be a key thing.
Yeah, definitely. But getting back to the initial point of our discussion about simple versus complex.
Yes.
Now we discussed about the frameworks, and it's obviously the new generations are a lot simpler than what used to have, and it seems that the simplicity is moving forward and forward. But then let's look at the other ways of doing stuff. Like you're the father of JBang as well.
Yes.
JBang, my feeling is that it's a love-hate relationship. I know people that love it, and then the other ones that are like, oh, Max did this thing, and it's a pain in the neck because of security, blah 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 blah. Is JBang a simpler thing, or it adds complexity?
Well, the way I think about it is like there's so many Java devs who've kind of fought so many battles of complexity that they just can't trust peace, love, and joy when they see it, right? When it's peaceful and quiet, you just can't believe that this is true. Like it has to be complex. So the way I see it is like JBang is just enough Java. And you can say I've removed stuff that was often never needed, or rather, I haven't added stuff unless someone found a need for it. So JBang started again. This came out from my being gone a year and coming back, and I had to like learn Java again. I was like, this is horrible. I'm like, this is like, how can we do this to people? So this was like Java 8 was the new thing back then. And I hadn't done real Java since Java 6 at the time. So I had to learn on like streams and other stuff. I knew what it were, but I haven't used them. So I said, hey, let's just try and have a side project for a while. And I saw someone using our build system was using Kotlin script, like K-script, I think it's called. And they basically just writing Kotlin because they like small single scripts because they could maintain. The Java people knew how to do that. And I looked at the code, I was like, this is just Java. Why don't we make that work in Java? And that's where it started. And it was like, oh, when I built it, it was like, wait, I can now experiment. Like, for those who don't know, it's JBang as you can, original idea was a single Java file, and you can add declare dependency in the top, like // steps, log4j, // steps, Quarkus, whatever. And I was like, oh, wait, I can now experiment. I can try new libraries like in seconds rather than start IDE, new Java project, find dependency. I could just literally just boot it up from it. And then Taco, who's my partner in crime in later versions of JBang, started adding this like automatic downloading of the ADK. So you didn't even have to have Java installed before starting with JBang. So this whole having to pick which version of Java you download doesn't matter. You just go and get Adoption at a time or Tamarin, the latest version. And now you could start with Java with just having like Notepad on your machine, which was the good old Java back in 20 years ago. Then the next thing was I can actually install the VS Code Java editing for you. So suddenly JBang was not just able to explore new Java libraries, but I could give it to a student and I could install and enable Java anywhere whether that was on my grandma's PC or my new laptop or some cloud IDE out there, because they were just these like simple commands. And it just grew from there. That JBang is nothing but a wrapper around Java C and Java and JShell for those who want to do interactive stuff. And I just kept that principle. So the cool thing is almost anything that the Java team has come up with, I either already had in JBang or can assimilate to JBang, right? So JBang works from Java 8 to Java, the latest early access version. It could also work back to Java 6 or even older, but it starts being hard to compile stuff in that range. But fundamentally, it is a very thin layer on top. And it's funny, this love-hate thing. Some people love it. Some people hate it because it doesn't come with a default 6 nested directories for like source main Java, IO, Acme, Bean, XYZ. I can just have one file, and this can be a small script, or it can be a full-end microservice written in Quarkus. Right? I like it, and I'm biased, but
that's the magic of the world. We have to live with each other, even if we have different opinions, right? Yeah. So JBang would be a proper tool to just bootstrap yourself if you want to do Java development, as long as you have an internet connection, more or less, right? And then just run it, and then everything will just work out of the box.
I have this claim, like in Quarkus, you have to claim that if you find out that Quarkus is slower than Spring, that's a bug, because fundamentally it cannot be the way it's architected. And with JBang, I say if you find any development environment in the world that is easier to install than this one, I consider that a bug. I'm a heavy user of Python. I'm a heavy user of Node.js and well, I'm not saying heavy use, but for front-end development, I've used it, and Go, and all those tricks and tools they use to do things, I've applied to JBang, so it just becomes so easy to set up, and it can self-bootstrap. But this is the fight I'm fighting, right? Like people saying JBang is not part of Java, so I can't use it. And I'm like, Maven is not part of Java, or Gradle is not part of Java. You use that. Oh, that's because people are like, that's what I'm used to. You look at Python, pip install is not part of, well, it is now, but pip started as something that's outside Python. NPM package managers are not part of the original Node.js setup. It's funny, like people just, no, this doesn't fit into the complexity of Java, and therefore it's kind of an outcast.
Yeah, well, that's usually the way. There are the people that are pioneers, and then if you look at the hype cycle as well, then you have the really early adopters, but most of the people are in the middle. They are either late adopters, or they are just waiting for the scale to be in the other direction.
Yeah.
How did you build JBang so that you ensure that things are safe, but also simple? Because simple, it's obviously they are.
Well, there's the thing, we can still do more, but JBang itself is using like the Maven resolver itself. Like, so anything that the Maven resolver does to security is there. So JBang doesn't do anything that is outside normal Maven, so to speak. One thing I haven't enabled yet, but I do want to get to, is shard, verifying of the CR signature. But Maven today, and even Gradle, doesn't do that by default because it slows things down. But stuff that JBang does that is unrelated to Maven is, for example, I can say JBang a file on disk. Again, no different than you can do with Java. You can say Java, single file Java, it will run what's on disk. So that's no less or worse than Java. But then I can use a UL, JBang a UL. And people go like, oh, I can run random stuff on the internet. But if you go look, JShell actually also can run ULs. People don't know. You can go JShell, HPS, something. There's no check whatsoever in doing that. In JBang, we have this notion of trusted ULs, so that the first time you go and get it, it will ask you, is this a thing you trust? And you say yes, then it's fine.
So that means that you have to whitelist it, more or less, right?
Yeah, it's kind of like if you ever use VS Code and it opens a UL, it says, do you trust this link? And then you say yes. And then from that point on, you can access that just fine. You can also trust the whole domain and that kind of thing. So I have that kind of notion. So in that sense, I feel like it's safer than even NPM and pip and other stuff out there. And I'm sure there's stuff you might have missed and stuff, but I encourage people, if they see there's like a security concern, do open it. But as far as I know, we are not doing anything not done anywhere else. And the places we could do stuff, we have added stuff in. There's the fun thing, like people realize what's it called, like this supply chain attack, right? That you can add stuff like, hey, you can patch a Maven plugin. If you somehow can get that released to a repository that you're building from, then boom, you have an attack vector. And people look at JBang, they realize, oh shit, I can do any kind of stuff here. But that's because it's so easy to do, where it's just as easy in Maven or Gradle to do things. Like there's a lot of open source projects that gets reproducers just attached to the project. And even me, like I just look quickly and go, okay, I'll just run it. But anyone could have put some code in there that are tricky. So I'm getting more and more cautious about that. But the world of software is a dangerous place to live. Let's just say that.
Fair enough. One last thing that you think that we as an industry are doing too complex things when there are simple alternatives?
Well, again, for me, we started a bit in the beginning, but it's something that's on my mind again and again, is this thing that just because there is this hype, people are just attracted to it like moths from somewhere. And they don't realize that, hey, you know what? There's actually already stuff out there that can do this stuff. Like combine the two instead, you'll get a better result. But also at the same time, I also very much aware of applying it to myself, being like, hey, I'm so used to things, how it works in Java. Remember to go look at how it is actually in the Python land and see how it is, because there is actually also simplicity over there. There's a reason why it's so big. So just as I've said, hey, don't diss Java and diss the Java ecosystem, it can actually be simplified and be good. There's still stuff to learn from that new world. There's complexity everywhere. There's also simplicity hidden in some of these new places coming up.
So just listening to you, one metaphor was coming over and over in my head, or maybe it's not a metaphor, it's more a comparison, is that whenever I was working with JavaScript and my colleagues from JavaScript side were coming and they're like, check out this new thing with, I don't know, Nest.js or whatever, other new stuff. And I said, yeah, well, that's dependency injection and it's in Java for ages, or mappers, or ORMs like Hibernate. Well, that's already existing for a long time. But my feeling is that also this old dog, that's Java, and that's there for forever, can learn new stuff from the newer generations. And that's very nice to see this symbiosis in the ecosystem.
100%. Like the day we don't learn from others and improve from that's the day that Java dies. And that's why I think Java is very much alive, because we keep learning and keep adapting. It's a different world, and yeah, we can definitely learn and improve. And we are. At least I'm trying to do my best in helping in that space.
Great. Thank you, Max, for the time. Thank you for sharing all these thoughts. Any last things that you would like to share?
Well, if you find some of this stuff interesting, definitely check out Quarkus and explore it, try it out at least. And yeah, for JBang, anyone who's doing Java, whether it's with Quarkus or Spring or Micronaut or Python or Kotlin or Groovy and Scott,
whatever other things are there.
Yeah. JBang actually has a place to do, because give it a try. Tell me what you think, even if you don't like it. I learn from it every time.
Great. Thank you for taking the time, Max. Thank you, everybody. And just make sure that you listen to the InfoQ podcast. We have great things to share.